Let's look into definite integration. We've been doing indefinite integration. So we kind of know what it looks like. We've said that, but what does that really mean? So let's look at a distance versus, or velocity, excuse me, a velocity versus time graph. And says if you travel at a constant rate of 40 miles per hour, how far will you have traveled after 1, 2, and 3 hours? And so clearly I know you can figure out these answers very easily, but I want us to look at something so we're really understanding what we're doing. So after 1 hour, of course, you're going 40, and I'm putting the units on there for a reason. 40 miles per hour. You're multiplying by 1 hour, and you say, well, duh, I would have gone 40 miles. All right. After 2 hours, well, again, you're going 40 miles per hour. You're going to multiply by 2 hours. Again, those units cancel, and I would get 80 miles. And I think we get the idea. After 3 hours, I'd go 40 miles per hour, multiply by 3 hours, and I would go 120 miles. So that's super easy and obvious. But let's see what that really means. Okay, let's look at something. Let's look, if I do 1 and I kind of make a block out of that, what would the area of this rectangle be? Well, it would be a 1 by 40, and so that would be 40. Huh, interesting. If I extended that out and said, you know, let's figure out what the area of that rectangle would be, well, I would have a 2 by 40, so the area under that curve there, that block would have an area of 80. And we certainly are smart enough to know that if I extended that out a little bit more, the area of all this would be 120. So it looks like, notice that the velocity is all positive here. And if I have velocity versus time, what the area under the curve looks like, okay, this is only if you have positive velocity, okay? It looks like that the area under the curve is the distance traveled, right? Well, let's see if we, let's look at the next example and see what's going on. With the next one, let's see, I mean, what's going on? So his velocity, obviously, it's not constant. So he's slowing down because the velocity is getting, you know, less and less and less. What does that negative mean? That's kind of weird to me. So let's just call this A1 and A2. So let's see how far he traveled in the first 2 hours. Or in other words, that would be the area of A1, right? So the area of a triangle, 1/2, base is 2, height is 40. So he would travel 40 miles. Now let's figure out, I don't really understand what this is, but let's just, for the sake of it, let's figure out what A2 is. If I just gave you that and said, guys, what's the area of that triangle? Well, it's also 1/2. The base is also 2, and I have 40 for a height, so that's also 40 miles. But what's going on? What's going on here? What does that mean? When the velocity is down here and the velocity is negative, that means he's traveling in the opposite direction. So he's going one way here when his velocity is positive. So right there, it's like he turns around and he's traveling back the opposite way. Now, how does that relate to integrals? Well, back up here, I could have written a definite integral, the integral from 0 to 1 of v of t, because this is a graph of v of t dt, and that would have been 40. That integral would be 40. I won't write all three of them. I'll go 0 to 3 of v of t, and that would have been 120. So is the integral of velocity, is that going to be the distance? Okay, and so let's look at what happens with this one. If he's traveling in the opposite direction, is it right for me to say that the integral from 0 to 2 of v of t dt is 40? Well, yes, that's true. But let's look at this one. What would this integral be? That integral, what you have to learn is, yes, you can think of area, but because this guy is below the x-axis, mathematically, that integral that accumulates that change is going to be a negative 40. So wait a minute. Let me figure this out. So we need to tell the difference. Up here we said that it looks like that the area under the curve is the distance traveled. Well, that was true if you have positive velocity, but there is a very big difference between these two things. If I ask you then for the integral of v of t of this problem, well, by one of our properties here, I can split that up. So that would be the integral from 0 to 2 and the integral from 2 to 4. So you can see what I would get for that is if I have 40 plus negative 40, that would actually give me 0. So does that mean he didn't, what does that mean that it's 0? And what you have to realize is that this doesn't necessarily represent the distance traveled. This is the total displacement. Now, oops, can't spell. Whereas if I said what is the integral from 0 to 40, sorry, not 40, 4 of the absolute value of v of t, if I ask you this in words, I say, guys, look, he traveled 40 miles there. He traveled another 40 miles. He just went in the opposite direction. Well, how far did he actually travel? His total distance traveled is the 80. So this is 80. So what you have to realize, are those things sometimes the same? Well, yeah. Back up here, if velocity is always positive, the distance traveled and displacement are going to be exactly the same. But you have to be careful when you have negative velocity, there is a difference between the total displacement and the total distance traveled. So you need to kind of memorize those formulas. But what we're going to look at today, and I just use velocity kind of to put it into something that you've heard about before, is we're going to find these definite integrals. And what you have to get right now is that the integral from a to b of f of x it can be interpreted as the area between the graph and the x-axis. But you have to remember, if it's above the x-axis, that integral is going to be positive. And if it's below, that integral is going to be negative. So notice that I went ahead and graphed a line for you. X plus 2 over 3 is, of course, 1/3 x plus 2/3. So I went ahead and drew that graph. on your homework. If it's not drawn, you actually have to draw whatever function is sitting right here, but I went ahead and did that. So it says find the values of the following definite integrals. Now, what we're doing to do that today is just geometry. So if I go from -2, which is right here, to 1, so I want you to shade what you're finding. You're finding the area of that triangle. And so this integral is going to be equal to the area of that triangle. And of course, we know that the area of a triangle is 1/2. The base is 1, 2, 3. The height is 1. So that integral would be equal to 3/2. And we'll do the calculus part later. Right now, we're just kind of understanding what definite integration is. If I wanted to go 0 to 4, that would be from right here to right here. So I'm looking for the area of this shape. Now I could divide that into a rectangle and a triangle, but it's much faster if you do it as one shape. So the area of a trapezoid, do you remember the trapezoid formula? You have 1/2. It's the average of the bases. So 1/2 base 1 plus base 2 times the height. Now, what are the bases and what are the height? Remember, the trapezoid has two parallels. Those two are the bases, and then the height is the perpendicular to those bases. So this would be the height, and this would be base 1. Doesn't matter which one is base 1 and base 2, but those would be your bases. So the area of that trapezoid, thus the area of this this value of the integral, would be 1/2. Base 1 is, where did we say that y-intercept was? That was at 2/3. 2/3 plus base 2, I could read that one off as 2, and the height is 4. So let's just get that together. I'll do the 1/2 and the 4, so 4 divided by 2 is 2. This guy, let's get a common denominator, so I'll change that to 4. Nope. I'll change that to, I can do math, 6/3, so that's 8/3. And so my final answer becomes 16/3. So that integral is equal to, that's ugly, that integral is equal to 16/3. All right, last one. This says -5 to 4. So I've got to go all the way here and then all the way here. Now, looking at that picture, is my answer going to be a positive or negative number? Well, ask yourself, do you have more above the x-axis or below the x-axis? There's more area above, so your overall answer is going to be positive. Now, what do I have to do to get there? Again, I'm going to divide these into two triangles so you can know what I'm referring to. I'll just call this big one A1 and this little guy A2. So let's do A1 first. What's the area of that triangle? 1/2 base 1, 2, 3, 4, 5, 6. 6 times 2. So I get the area of that one is 6. Now what is A2? 1/2. Base is 3. Height is 1, and so I get 3/2. But because A2 is below the x-axis, that integral is going to be negative. So, and people go, wait, area is never negative. Yes, you can use the idea of area to get these values, but you have to understand that the integral is not solely area. It is an accumulation of change. And so if it's below the x-axis, to get that final answer, I need to take 6 minus the 3/2, and that would be, change that to 12/2, so that would be 9/2. And that would be the definite integral of that. So a definite integral accumulates that change. And what you're going to be doing on your homework, again, you're doing all of your homework with geometry today. Drawing pictures, understanding what you're finding, and getting those values. All right. Peace out, peeps.